dog mad?
Me!
Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solving perimeter is
2 times width plus 2 times width.
And welcome to the elementary edition of Count on Us.
Howdy.
I'm Miss Shirey,
Mr. G.
and we are here to help you today with your math homework.
The place to be.
The place to be with Mr. G. We hope that you
And
have
Miss
some
Shirey.
homework. Hey, that all rhymes.
like
You're
that?
funny today. Mr. G is being really funny. I hope you've had a great funny day. I hope you have been working on some math today, and I hope you have a challenging problem. It's so challenging that you'll need to call for
us.
a little bit of help today.
There's no snow, so you can't throw any. It's all gone.
That's right.
Well,
It's
most of
melting away, melting away.
Melting away.
Yes.
It's melting away.
Melting
No
away.
snowballs for you.
So give us a call, 301-772-0080. The number is at the bottom of your screen. The bottom of your screen. And we also have some challenges today.
Do we?
Yep, in case your homework is just so easy that you don't need us, you don't need our help. We have 2 challenges today. One is the word scramble. And yes, these letters do make a word.
It's hurting my head just
I
to
know.
look at that.
I
Yeah,
I don't think that's the word, Mr. G.
I don't think it is a word.
I don't know, but I'm sure our callers can figure it out and unscramble the math word.
It's a math word?
Yes, it's a math word.
It's an awfully long math word.
It is, but I bet they can do it. Our other challenge is, of course,
24.
Mr. G, would you like to go through the cards?
So you have to take these 4 numbers on any of these cards, and you have to calculate them to equal 24. So card A is 8, 2, 6, 1. Card B is 7, 4, 4, 2. Card C is 5, 9, 4, 8. And card D is 3, 3, 3, 5.
There you go. All right, so write those numbers down. Take a minute. Make sure you have all the numbers correct on each card. Work on them. Work them out. There's always more than one way to figure them out, too. So once you work them out again. Figure out another way. Okay, so work on those during the show, and we'll see if you get them right. Okay? So those are our challenges, Mr. G. So what else is going on in math?
Math, I don't know. We've had so many snow days. I don't even know.
I know, but we were just talking about the mathematical practices, and maybe we can work on some problems that really make us think and use our practices.
Well,
today.
you always have some doozies.
I don't have any doozies today.
I don't have any doozies.
Well, we were working on money, and I do have a problem that could be a little challenging for K through 3.
Okay.
Okay, so we were working with some money, and this was the problem. It was Bob. He gave his sister, Bob gave his sister Alice, that's her name, Alice. He gave her 40 cents for ice cream.
Oh,
I know, because he's a nice brother. And then he had a walk, like they were at the ice cream store, and then he was walking back home, and he had a hole in his pocket, and he lost a dime. In the hole in his pocket.
he probably didn't hear it drop either.
Nope. He wasn't paying attention because the thing was he wasn't being irresponsible. He was taking care of his sister.
I do not like losing money.
I know.
Ugh.
And then when he got home, he had 25 cents left.
Oh, so I bet I know the question.
What's the question
The
going to be?
question is, how much did he have to start with?
Oh, yeah. And this was a great question because the second graders just wanted to add up all the money. You know, they just wanted to start adding things or subtracting things because they're not really thinking about what the problem is asking. And yes, the problem was, how much did he start with? So actually, we're going to have to go backwards.
I want to know where he lives where he can get ice cream for 40 cents.
40 cents, it's a deal.
Yeah.
You know, Bob and Alice, they got a sale.
It's like
you
a
know.
spoonful today. I don't know.
Maybe it was just a small ice cream cone.
Okay,
I
all
don't
right.
know. But so anyway, that was the problem. And my
it's
kids
meaty.
actually had to work on it a little bit.
It's meaty.
It wasn't just the here are some numbers and here are some numbers and how many in all. We already know how to do those.
Okay.
So this kind of made them think the other day. Do you know how to do it, Mr. G?
I think so. I think in this case you do have to add them all, right?
You do, and you have to work backwards though. And it was a little tricky because in the problem I said he lost a dime. I did not say he lost 10 cents. So that was good for them to try to remember, okay, a dime's 10. You know, so it's just a little warm-up. This is a little warm-up the other day.
It's a warm-up.
Oh,
Okay.
yeah, just to get their brain moving. We do a lot harder problems in second grade, Mr. G.
Ooh,
Don't
really?
discount us.
Oh,
We are
okay.
working with lots of money and quarters and dollars, and we learned how to add money, too, with decimal points, but we'll get to that later.
Okay, well, you know, I hang out a lot with the 5th and 6th grade. I mean, I hang down in the lower grades, too, but, you know, they're doing all that higher level stuff.
I
But
know,
this is
I know.
pretty challenging.
It's like I said, it's a warm-up for us.
You have to understand what's being asked.
Right, so we actually, we acted it out, and they liked that. That was fun. So we did some acting out,
You had
but
students who were 25 cents and students who were 40 cents?
yeah, I had someone be Bob and someone be Alice, and Bob was walking,
okay.
and you know,
I
we
thought you
did,
had like, I'm a quarter.
no, we
Okay.
did Bob and Alice.
Gotcha.
But you're right, we do have to kind of do some adding and figuring stuff out. So if he got home and he had 25 cents,
Okay,
I know
we could start with that.
I know he had that.
So you said work backwards, so we ended with 25 cents.
Yep.
Okay.
And then if we worked backwards through his day, we found that he lost a dime, so that would be 10 cents.
Ugh.
A dime is 10 cents.
Don't like losing money.
No. And then
Okay.
he was super generous and gave his sister 40 cents.
He didn't even buy one for himself.
Nope, he didn't. He was saving it.
He's a good guy.
Well, he really couldn't, because you'll figure out that he gave her 40 cents, but if he had a dime and a quarter in his pocket, he really couldn't buy any for himself anyway.
Right.
So when
have
I
to
add
admit
that
he's
up-
a better big brother than me, because I don't know that I would have
Well, maybe they shared it. I don't know.
spent more than half.
4
my
plus 2 is 6 plus 1 is 7. So he started the day with
money.
70.
75 cents.
Now, we could have gone on, that would be a great question, and I kind of already answered it, but if one ice cream cone costs 40 cents,
Does he
two
have
ice cream
enough?
cones would cost,
Well, yeah. Does he have enough?
does he have enough to buy one for himself?
2 ice cream cones.
And the answer is no, because if I count by 4s, it's just like counting by 40s, and it's 80. He would not have had
That's a
enough money.
cool big brother. If he said, "Hey, I'm gonna get some ice cream,"
Yeah.
and he didn't even get one for himself, or did he eat half his sister's ice cream?
Maybe. Yeah, maybe he just told me that for a nice story. I don't know. But anyway, that was one of our warm-up questions.
Very good, very good,
Yeah.
very good,
Yeah.
very good. Well, you know, I was hanging out with 5th grade today
Oh, fifth
for a little
grade.
while. Not
Okay.
a long time, but for a little while. And they were working on a coordinate grid
Oh, yeah. I
and
like the
ordered
coordinate.
pairs.
Oh, excellent.
Yeah, yeah.
Excellent.
So, you know,
What you
I
got?
have some graph paper.
What?
Woo-wee, I came ready
Ooh.
today. I came ready
I like that
today.
graph paper.
See my graph paper here?
It's very nice.
So we were talking about how do you labels. Do you have a ruler over there?
I don't know. I will look and see.
We were talking about how to
You can use
create
this
the coordinate
temporarily
grid. Okay, we can have
until I find a ruler. There must be one
a
somewhere.
straight edge here.
Oh, I
Ooh.
found it. It was hiding from me.
Oh yeah.
There you go.
Oh yeah. So we can make my straight edge here.
Oh, so it's more visible. Yes, on the screen
Yeah,
that's much more visible.
So we know that the horizontal line is X and Y.
Right.
And then all the lines are numbered. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if I wanted to make a shape, it really depends. You could have the coordinates already given to you.
Okay.
Or what I'm going to do is I'm going to create a shape. So here's 1. So how do I do this? How do I read this? First, every ordered pair starts with X, or it goes across, and then it ends with Y, it goes up and down. So how I do this is 1, 2 across, and 1 up.
Oh,
so this
okay.
is ordered pair 2, 1.
Mm-hmm.
And then I can make another one. And that would be 1, 2, 3, 4, 5, 6 across.
Mm-hmm.
So that's 6, and then 1 up.
1 up. Okay, I see.
Right?
Mm-hmm.
Now, if I make this right here, boom, that's 1, 2 across, and 1, 2, 3, 4, 5 up. So that's 2, 5. And then 1, 2, 3, 4, 5, 6 across.
Mm-hmm.
And 1, 2, 3, 4, 5 up. And what
Nice.
do I have here? Well, if I connect the first one to the second one, and I really did this kind of out of order. I did the first one to the third one. Ta-da! What do I have?
Ta-da! You have a square.
I have a square.
Yay!
Now, if you can really tell, because look, I have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4.
4 rows of 4.
4 rows of 4.
Excellent. That's cool.
That's a square. So you have to know that the numbers going across are your X. The numbers going up and down are your Y. And that's the basic learning step 1 of the coordinate grid.
Wow, that's not so hard.
It gets really cool when we start going into, the other side. And all of that.
Negative.
Yeah. So
Wow.
this is called quadrant 1.
Aha. 1.
And it always has an X and a Y that are both positive numbers.
Very nice. Wow.
When they go on to the 6th grade, they start talking about quadrant 2, quadrant 3, quadrant 4, making all these kind of cool
Excellent.
shapes all over the place.
Very nice. That sounds great.
Yeah.
Now, do you all do like adding and subtracting integers at all?
Ooh.
Is that like 5th grade or is that 6th
That's
grade now?
more 6th grade, but those superstar rock stars, they're starting to get some of that in the 5th grade.
Yeah, I know at the end of 5th grade we used to start doing a little bit of that.
Man, they start talking about absolute value and all that good stuff. And
Wow.
That's the middle school show, so that's like the next hour.
Okay. So I'll stick with the coordinate grid right now.
Yeah, and you can make some pretty cool pictures and shapes and all kinds of good stuff. with that.
Excellent.
Just in the first quadrant.
We haven't gotten to geometry yet, but when 2nd grade does, we are going to knock it out of the ballpark. I cannot wait.
I love shapes.
Yeah, we're going to put them in groups. We're big on grouping in 2nd grade.
Oh.
You want to see how I put stuff in groups?
Sure.
Okay. I need a work mat here. Well, this is how we talk about shapes.
Okay.
I tell them when they come to 2nd grade to forget everything they learned about shapes because
Forget everything.
forget everything.
Oh my goodness,
Yeah.
you're going to start from scratch?
start from scratch because
You can't forget what you already know.
well, I tell them
Unless
to
you're like-
forget because sometimes they learn it wrong or they come at it from a different perspective.
I don't say forget it. I say we have to untangle some things.
Untangle, I like
know
that.
that
We're
you
going to
can forget
untangle some
Yeah,
things.
yeah, we
So
can untangle.
basically, we have different discussions about shapes, and mine
Mm-hmm.
aren't as nice as yours. But I was trying to.
Well,
find
I had
a
lines.
square,
I had
right?
lines, to be fair. I
Right,
had
but
lines.
you can tell the difference between these two. One is a square and one is a rectangle,
Got you.
and we'd have different conversations about, what group. Oh, my rhombus is really bad looking. But that's supposed to be a rhombus. That's supposed to be a parallelogram.
Gotcha.
And we just look at them and put them in different groups. And we talk about members of each group. And we say the square and the rhombus can be the member of the same group because they have 4 equal sides.
Or they could be different
Or they could be different.
based on their angles.
They could be.
Ooh.
The square and the rectangle are a member of a group because they don't have slanted lines. We start there with 2nd grade and then we talk about angles. But at first we just start making groups and members of groups and thinking about the characteristics of each group.
Okay.
So that's a fun thing to do with geometry. But
So you don't talk about cute little angles?
no, not in 2nd grade.
big obtuse angles.
No, we do not.
Okay.
No.
Okay.
So, but But what else is going on in the 5th grade? Just coordinate grids?
Coordinate grids. What else did we talk about?
We're just talking about money in 2nd grade. But we can talk about...
Just money?
Just money, really. Anything to do with money. We're really talking about... We did some problem solving the other day with making a table. And we're going to do another one of those tomorrow because we're going to start talking about 4 quarters is a dollar.
Okay.
We kind of really talked about that, but our warm-up tomorrow is going to be a question like this. Bob
You're
earned...
giving away tomorrow's warm-up?
Yeah. Well, if they're watching, then they'll know. Okay. Bob earned 25 cents for taking out the trash.
He's rich.
And my question to them was, how many times does he have to take out the trash to earn $6?
Oh, that's a whole... Does that mean he can take it outside, bring it back in, take it outside, bring it back in?
No, Mr. G, you have jokes today. No.
We're talking about totally separate days?
Totally separate days. So every day he takes out the trash. It's like 25 cents a day.
Oh, my goodness.
No. So he's trying to save up $6 for this toy.
I think Bob should make me his agent so I can talk about him getting more money.
More money a day, maybe 50 cents a day?
That's rough.
Well, he only earns a quarter every time he takes out the trash. And I want to know how long till he gets to $6.
A year?
And it's not that long.
It's not?
No. In 2nd graders, that's a good warm-up problem.
It is if you're trying to save $6. It's a long time.
We talked about drawing a picture first. First, they were drawing pictures, which is great. That's the first strategy we had. But then tomorrow, we're going to talk about how to make a table and how this is so much more helpful.
Okay.
So we're going to talk about every time.
That's a lot of circles with 25 cents in them.
Yeah, but they can do that. They know this so far. They know that 4 quarters makes a dollar. So they're good at withdrawing pictures. But I said there's a much more efficient way. That's our word of the year, efficient, by the way.
Efficient.
You have to be efficient.
I like that.
So every time you have 4 quarters, that's $1. Guess what happens? When you get 8 quarters,
you
get $2. And they can look at their picture and figure this out.
So that's 8 times you have to take out the garbage.
Every
12
time.
times
12
you have to
times.
take out the garbage to get $3.
That's right. And you can track all the way down. And they can figure it out. If you make a table, it's much more efficient. And I will have kids that will recognize that this part of the table, it's a pattern, Mr. G.
Look, that's the 4 times tables.
That's right, counting by 4s.
4,
Well, we
8,
call it
12.
skip counting by 4s.
So I can make a prediction. Next is going to be 16 times and you'll get $4.
That's right. So if I want to go to $6, I kind of ran out of room on my chart. But if you want to get all the way to $6,
right, so 4 times 6
is
24.
So he would have to take out the trash 24 times. That is not even a month. See, it's not a year, Mr. G.
Yes, it is.
No.
They only pick up the garbage twice a week in my neighborhood.
No, you're just taking it out to the big trash can. You're not picking it. They're not picking it up every day.
Well, that means you're just going to try to make a bunch of garbage so you can get
maybe, but Bob is
Mom took out the garbage
Bob
today.
has much more integrity than that.
He
So
does.
it's going to take him 24 days. It's not that long. He's going to have his $6 and he's going to be able to buy his toy.
Bob did get an ice cream for his sister, so maybe he does have some.
We're really talking about the mathematical practices of structure and looking for patterns, things of that nature.
That is looking for a pattern.
So yeah, that's what we're doing.
But this is great too because it's representation.
Yeah, drawing models. We're really big into models. I told them you
That's
have
really
to draw me a picture or show me somehow.
Right.
You can't just figure out the problem. You have to show me how you got it.
Well, you can just figure out the problem, but you have to prove how you
Yeah,
figured
if
it
you
out.
have to prove it. And even with mental math. We've been doing a lot of mental math. You want to see some of our mental math?
Absolutely.
It's really awesome. Okay, we just finished a lot of adding and subtracting with mental math.
Okay.
And this is probably, too easy for your 5th graders, but
You think so?
yeah. So let's say you have 199 and you're trying to add 38 to that.
Ew.
Yeah, that would get real messy if you had to add it the traditional way. The traditional algorithm where you just, you have to regroup and write it all out and all that stuff. But you don't have to do that.
You could just round them.
You could. But we like to do something called splitting.
Oh.
Yeah, and 2nd graders know that 199 is just one jump away from 200 on the number line. So if it borrows a 1, you can actually split 38 into 1 and 37.
That was so easy. So that's
And then
237.
Then all of a sudden you jump to 200 plus the 37 I never used is 230.
Right, because those nice round numbers, those
friendly
zero
numbers
are friendly.
Friendly
That's
numbers,
exactly
we
what I
like
was
to call
gonna
them.
say.
Yes, and 199 is not friendly.
No,
it's
it's
kind of
not.
unfriendly.
It's not.
It's kind of a bully. But yeah,
I like
so
that.
that's some of the
I
stuff we
like
did.
that.
Yeah.
Well, in the upper grades, I usually tell them if they go grocery shopping, what they have to do is they have to estimate what the bill is going to be. They go, "Oh," and I tell parents that. Like, why'd you tell my mommy that?
Estimate
So
the bill.
you can develop your math skills.
Estimation is a great part of math skills. You have to learn to estimate.
Absolutely. The reason why I do this is because I always get in line behind somebody who doesn't have enough money.
Oh.
And then they have to spend another 5 minutes trying to figure out what they're going to not purchase.
Put back stuff. So annoying.
That drives me crazy. But if you kept a running total in your head as you were picking your items and putting them in your basket, you can figure this stuff out. So you'd be like, okay, I'm at my limit. I can't take another thing.
Right. No more. So how
No
does this work?
Doritos.
No Doritos.
No
Oh,
Doritos.
no. Gotta put them back. Get a healthy
Put
banana.
the Doritos back. Get some fresh
pineapple,
fruit.
that's right.
There you go. So you can round these to nice whole numbers, and it makes it a lot easier for you. So $2.39.
Right.
I can round to $2.
Oh, okay, that's right. It's about $2.
$4.17. I can round to $4. $5.75. I can round to $6, and that comes to $12.
Oh, and second graders would know how to do that mentally because we know 6 and 4 makes 10 already.
There you go.
And
There's
10
a
and 2 is
10,
12.
and then there's a 2.
Yeah, we're good at making 10s.
All right. So then you could, now what I usually challenge the 5th graders is this a overestimation or underestimation? So then when we have numbers like this, let's see, that's a little, so breaking that up again like you said,
Yep.
I can take 1 from that 7 and make that 10. 10 and 6 is 16, plus 16 and 4 is 20, plus 1 is 21. Boom. Look at that. 7 and 3 is 10, 11, 12, 13. Decimal. What do we have here? 5, 4, 9, 10, 12. Look at that. $12.31.
Pretty close. Very good estimate.
Now, of course, there's going to be some tax in there, but
course.
you know, if you have $20,
You have plenty, right?
you have enough. If you have $10, something's got to go back.
That's right. You can't take all that home
It's
with
just
you.
not going to happen.
Wow. Well, that's cool. We've been doing a lot of that too because I taught my kids how to add with decimal points.
Yes.
Even in second
very
grade.
important. Very important.
Yeah. Can I show you something?
Sure.
Okay. Can I erase your problem?
Okay.
Okay.
I won't be upset.
Okay.
My wonderful work.
I don't want to upset you. But we talked about translating like 7 cents, and what that means is that is 0.07 or
This is second grade?
7/100. Well, no, this is just kind of bonus because
Okay.
we've been adding some money. We're
Okay.
doing some fundraising, and at our school, and when they bring in money, I want them to understand the difference.
Absolutely.
Because
And
some
you
kids
tell
were
them-
getting the wrong answer.
You tell them that's 7 out of 100.
7 out of 100, 7 pennies out of 100. And then some people, instead of writing 1 cent, they were doing this. That's not 1 cent, that's 10 cents. So just knowing how to translate it into decimal form. And then lining up the decimal points. I said, boys and girls, adding and subtracting decimals is so easy. You just do it the same
really
way.
is.
All you have to do is line up the decimals.
But you have to line your numbers up as well.
You do, because we had people bring in, people with totals, let's just make something up, $1.47, and then someone else would have $27.53, and then someone else would have $4.20. And you just have to make sure you don't put the 4 under the 2 because
Right, because that's
you
$40.
have to line
not
up.
4.
That's right. You have to line up the decimal
Now, if you're
points.
paying me that, then,
Ha ha, you're
bad
funny.
mistake. But,
Yeah.
if you put that 4 in a lower place, then
No,
I'm
we're always
gonna be a
looking
little
for
upset.
new opportunities for our second graders. Yes.
Sounds
Because I
like
used
a
to
lot of
teach
fun.
upper grades, so I'm used to that hard math.
There you go. So you challenge them.
Challenging.
There
Very.
you go.
Yes.
All right.
So what else is going on in 6th grade or 5th grade or?
6th grade, well, 5th grade, they've also done some
grade.
fraction stuff. They were doing a lot
Okay.
of fractions with unlike denominators.
Oh, this can get so messy.
It
But
could, it
honestly,
could.
if you can switch out money, when you're in second grade, you can swap out fractions and make equivalent fractions.
Right.
Because that's what we
they're
talked about too
interchangeable.
when we were doing money. We talked about equivalent coins. It's just like equivalent coins. 2 dimes and a nickel is the same as a quarter.
Ah,
You know,
you
4
just
quarters is the same
trade
as a
'em.
dollar.
There you
So if
go.
you have 1/2, it's the same as 2/4. You're just swapping things out, just giving it different
Oh,
names.
so
You're just renaming things. Things can have different names
you
in
said
math.
if you have 2 quarters,
2 quarters, yep.
so 25,
Mm-hmm.
and a 25, you're saying that's the same as 1/2?
That's right, half of a dollar.
Because that's the same as 50 cents or 5/10.
Mm-hmm. Or 50 hundredths.
5/10 or 50 hundredths, they all equal half.
They do. It's just a different name for it. It just looks different,
that's
but it
so
means the
cool.
same.
That's really, really cool.
Yeah, you have to know how to do equivalent stuff in math because sometimes you want your numbers to look this way and sometimes you want it to look this way. And sometimes you want it to look this way or this way. You have to use what's most efficient.
Right, because you could also make that equal.
That's right, you could. Or you can make it
Fractions,
2/4,
decimals,
like 2 quarters out of 4 quarters.
Oh, there you go. Well, you have 2 out of 4, which simplifies to 1/2.
That's right.
And you start the cycle all over again.
Yep, so that's the big thing in second grade with my kids. I'm teaching them to be the most efficient way to solve the problem. Efficiency. What do you want your numbers to look like? What strategy is going to get you the result the fastest and the most accurate?
Mathematicians have to be efficient.
That's right. That's right. Because, and it's really true because nowadays mathematicians are working with huge bits of data, not like we used to have 50 years ago. They're huge bits, and you're overwhelmed by all this data. You have to know how to deal with it efficiently.
Absolutely.
So even
and
in
the jobs of the future are a lot of math,
Yep.
a lot of science, a lot of
Absolutely.
technology, a lot of engineering. So get into it now. And it's going to be a wonderful thing for you in the future.
That's right. It's all about efficiency, knowing your numbers, knowing
Yeah.
patterns. Well, we were just doing money. That's really it right now. We're really focusing on money,
Okay.
doing a lot of money stuff. I don't know what the other classes are doing because I'm just doing money with second grade.
Well,
That's been my focus.
I'll do those unlike denominators we were
Oh,
talking about
unlike
earlier.
denominators.
Unlike denominators,
there's-
'cause that seems to always be a challenge. So,
But they're really not. I didn't think of it really until today about money. It's the
if
same
you're
as money.
struggling with it,
But it's just another name for
So-
the same piece.
2/3,
Uh-huh.
and let's take 5/6.
Mm-hmm.
Ew, and we're gonna add them.
Oh, that's going to be hard.
Ew, you think so?
Yeah. I think so.
Well, we can talk about the concept of the least common multiple, which is going to become our least common denominator. So least common multiple means all the numbers that are in the 3 times tables, all the numbers that are in the 6 times tables. So we did the 3 times tables, it would be 3, 6, 9, 12, and I don't have to go too far because if I do 6 times tables, it would be 6, 12, boop, boop.
Oh,
There
right
it
there.
is.
6. There it is.
So what that means is I don't have to do anything to the 6, but I can, the thirds are bigger pieces and
That's
I
right.
can turn them into 6. I
Okay.
can break them up. So for every 1/3, I have 2 6. So 3 times 2, 2 times 2. So 2/3 is the same as 4 6.
Oh, okay.
And just for consistency, 4 6 and 5 6, we're putting them together.
Right.
They don't stop being 6.
Right. Just a name.
Just a name. And then 5 plus 4, 9, 6.
Awesome. That
Now,
that looks a little
we
ugly,
have,
though.
we have a whole new problem here.
It's unfriendly.
Because it's unfriendly.
Actually, it's not unfriendly. If that's
It's just a
the
little
form
different.
that you would need it, then that would be fine.
You could say it's unfriendly, but it's called, and I don't like this name more so, it's called an improper fraction.
Yeah, I don't like that name either. Because
It's called improper because the numerator is larger than the denominator. So whenever we have that happen, that means we have a whole amount that we can take out of it.
Yes, we can. Because
So-
I know 6 6 is the same as 1 whole.
There you go. So if I take 9 6 and I take out 6 6, which is the same as 1 whole, that's going to leave me with 1 whole. and 3/6 left over.
Oh, yeah. Okay.
And guess what? I'm still not done.
Oh, you're not done, no.
Not done, because talking about efficiency, you always have to simplify.
Right.
So instead of having 3 out of 6 pieces, I want the least amount of pieces. So 3 and 6 share 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So my total answer is 1
and 1/2.
half.
Oh, that's like saying I want 1 dime instead of 10 pennies.
There you go.
Oh, I get it now.
There you go.
Oh, well, that's some hard math. But you know what? I bet my kids could do that.
It's not hard.
No.
It's challenging.
It's challenging.
But it's
yes.
not hard.
But you know what else is challenging?
What?
All this math, and we need to take a break.
You need a break?
We need a break.
Go get a snack and come right back.
We'll be right here.
Go get a
See you in a minute.
snack and come right back.
Hi, I'm James. I'm from Tilton Elementary School. I'm here today for the email question of the day. Mary needed to place a fence in her yard in order to keep her sheep in. If her yard is a rectangle with a length of 26 feet and a width of 20 feet, how much fencing will she need? Well, let's take a look. So first, I would draw a rectangle to represent her feet. Then I would draw 26 feet at one side and 26 feet on the opposite side. Then I would draw 20 feet at one and another side, and then 20 at the opposite side to represent the fencing. Since we're talking about perimeter, since I have to do perimeter, I have to add all the numbers. 26 plus 26 plus 20 plus 20. 6 plus 6 equals 12, so I'll put the 2 at the bottom and carry the 1. 2 plus 2 plus 2 plus 2 equals 8. Then I'll add the 1. That equals 92 feet. So the fencing of her yard would be 92 feet. That's it for the email question of the day. Stay tuned for some more on Count on Us.
Does retirement have to wait until my 70s? Is a great college for our kids?
Out of the question?
Is the American dream
Out of our reach?
Not if we can help it. We're the National Endowment for Financial Education, a non-profit organization dedicated to helping people just like you get smart about their money. Log on to smartaboutmoney.org today and start taking control of your financial life.
He was so inspiring.
He took chances.
He was so moving.
He lived daringly.
Martin Luther King Jr. was a man of service, and his day shall be a day of service.
He inspired us in words, but he led us in deeds. To honor him, let's do the same. Go to mlkday.gov and find out how to volunteer on Martin Luther King Day and beyond. This message is brought to you by the Corporation for National and Community.
Okay, guys, ready? Here we go. Let's smile and brush our teeth twice a day, every day. Let's smile and floss our teeth once a day, every day. Let's keep that smile a happy place on your face with good nutrition and dental visits. Let's smile. Let's smile. Let's smile. Let's smile.
Welcome back to Count on Us. I'm Miss Shirey.
Mr. G, the place to be. Hope you got your snack so you can come back and be with us.
I know. I think someone did come back to be with us.
Did they? We have
did.
a caller. We have a caller. We have a caller. We have a caller.
You are so funny, Mr. G.
All righty. Who's out there in TV land?
Hello?
Hi.
Hello? Who is that?
Hello?
Who's out there?
Salafina.
Salafina?
Mm-hmm.
Hi, Salafina.
What school are you calling from?
Glenarden Woods.
Wonderful,
Glenarden's in the
wonderful, wonderful school.
house.
And what grade are you in?
4th grade.
Wonderful. 4th grade is the best ever. And how can we help you today?
I'm dividing mixed numbers.
Dividing mixed numbers.
Really? In the
Oof.
4th grade? Wow.
That sounds tough. Okay, can
What's-
you tell
what's
us
your
your
problem?
Yeah. Whew.
The problem is 2 1/8
Okay.
divided by 6 1/4. I mean 1/3.
6
Wow.
1/3.
Did you work on these in class?
Yes.
Okay. So you know what has to happen to these mixed numbers?
Yes. you have
Okay,
to
so what
change
happens
them.
to 2 1/8?
You have to change them into improper fractions.
Great. So what does 2 1/8 become?
It becomes 17/8.
Excellent, excellent. Right now I'm going to keep the division the same. What happens to 6 1/3?
19/3.
Wee. Good. Now, do you know what's next?
Yes.
What do you have to do?
Well, keep 17/8 the same,
Mm-hmm.
and then you have to change the division sign into a multiplication sign,
Okay.
and then you find the reciprocal of 19/3,
Which is?
which is 3/19.
I love that you use great mathematical vocabulary.
She
You said
does.
the
Reciprocal.
reciprocal. So your teacher taught you KCF?
No.
No? Okay. Because a lot of people say keep, change, flip, which is what you did. But that's fine. Okay, so can you simplify here at all?
No.
No, no. So this is one, unfortunately, where you have to do all of that math. Ugh. So what are we going to do first? The 17 times 3?
Yes.
Can you do that mentally? What's
yes.
3 times 7?
And is it 41?
Okay. Not 41.
21?
So that's 21, and that 2 will go here. So 3 times 10 is 30, plus 20 is 51.
Oh.
You want to see it?
Mhm.
17 times 3, so 3 times 7 is 21. The 2 goes in the tens place, so that's 3 times 10 is 30.
Oh,
Plus
okay.
2 is 50. Ba-dum-bum. So I was challenging you to do that mentally. Okay, now this one's a little bit tougher. So 8 times 9 is?
72.
Good, and put the 70 in the tens place. So 8 times 10 is?
8 times 10 is 80.
80, and 80 plus 70?
87.
80 plus 70?
Oh, 150.
Right, because 80 plus 70 is 150. So then, can you simplify this? And if my memory serves me correctly, I believe 51 is a prime number.
Mm-hmm.
Yes? Are you with me?
I don't think you can simplify those numbers.
Right. Do you understand what I said? I said 51 is prime.
I know what prime and composite.
Good. So 51 is prime, and it is not a factor of 152.
But 152 is composite.
Absolutely. So watch this. 51 3 times is going to give us 153. So 51 is not a factor of 152. So therefore, you're right. It's already simplified. You can't simplify it any further.
Okay.
But you sound like you have a very good command of all this fun math stuff that you're learning.
Does.
Very good. Keep it going so you can be an engineer and make lots of engineering money.
Good job, Salafina. We're going to put your name in the treasure chest. And right now, you're our only caller. So you have a 100% chance
You
of
are
winning.
going to win so far.
Can I do a challenge?
You sure can. Which one would you like?
24.
24.
Dun, dun, dun. Here they are again. Here are the cards, A, B, C, and D. Which card would you like?
I have the answer to A and B.
A and B? Okay, so pick one. Pick one.
B.
B? Okay, so that's 7, 4, 4, 2. Okay, go for it.
7 minus 7 minus 4 is 3.
All day, every day.
Okay.
4 times 3 is 12.
Okay.
And 12 times 2 is 24.
Woo! Good job. Excellent job, Salafina. Excellent job. So we're going to put her name in again. But she still has a 100% chance.
You're a rock star.
I'll put her name in. Excellent job. Thank you so much for calling.
You go, girl. You go, girl.
All right. And you tell your teacher we said hi from Count on Us, and you keep up the good work. You sound like a very capable young lady.
Who's your
very
teacher,
impressed.
Salafina? Are you there?
Hello?
Who's your teacher over there?
My math teacher is Miss Harding.
Tell her we said hi.
That's right. She must be doing a great job with you. You're both working really hard. Thank you. All right, have a great day. That was awesome.
That was awesome. She said reciprocal.
That's right. She said she knew about prime and composite numbers. I love prime numbers. They keep everything safe.
She's 4th grade.
I know.
She's going to be a scientist.
I can feel it. She
Engineer.
has a lot of capabilities. I can hear it over the phone. It just flows in, Mr. G.
It felt so good. I just love math words.
She must be a wonderful
they get
student.
me so excited.
You're too funny.
Or maybe it's just the air conditioning. Getting cold.
It's so cold in here. All right, Mr. G, what else are we going to talk about? Because obviously either people are just working hard, persevering on their math homework, or they're so great at math that they don't have any questions right now.
So, what did we do? We did division of fractions. We did multiplication of fractions. Did we talk about just changing unlike denominators to like denominators?
No,
did we do that?
We didn't. No.
Or
We could do some more dividing fractions.
Dividing fractions?
We could. One where you could simplify or reduce before you multiplied. That was a tough one. That's why Salafina's was so horrible, because it just couldn't simplify. It just had to multiply all those large numbers. Let's see what you have.
What was that, a division problem?
Yes, it was dividing.
Divided by
mixed numbers.
4 and 1. Nice.
Ooh,
How about that?
Okay. Let's see what happens.
It's ugly. All right, so first, you can change this, 2 2/3. You multiply, what this is saying when we do this is that whole number is broken up into thirds. So 1 whole has 3 equal parts, 2 whole has 3 equal parts, and then we have 1, 2. So altogether, that's 1, 2, 3, 4, 5, 6, 7, 8. So 2 times 3 is 6, plus 2 more is 8.
2 full groups of 3.
2 full groups of 3. So that's why we're multiplying the denominator times the whole number.
Oh, I get it. Okay.
So that becomes 6. 1, 2, 3, 4, 5, 6. The whole have 6 thirds in it.
But we have some that isn't a whole.
So then, that's the 2 over there. So altogether, 6, 7, 8.
Wow.
So that's 8 thirds.
Oh, I get
and
it.
then, do the same thing over here. So each of those fourths is broken up into 9 pieces. So if it's a pizza, you're really getting just a sliver.
Okay.
So 4 times 9 is 36, plus 1 is 37 ninths. Oh, so that's supposed to stay division, right? And then
you're going to flip it.
You can flip it because of the reciprocal. And when you do that, that's the key to tell you that you also have to change your operation.
You do.
So that becomes 8 thirds times 9 37. So that's some ugly numbers. But look at this. You could just do straight multiplication.
You could.
But what's going to happen is you're going to wind up having to simplify.
Right.
So you can simplify
now.
first. So what happens here is 3 and 9. You can simplify because 3 is a factor of 9, and it's a factor of itself. So 3 divided by 3 is 1. 9 divided by 3 is 3, and this becomes a lot easier. So 8 times 3 is 24, and 1 times 3 is 37, and 37 is not a factor. 24 is not a factor of 37.
No.
So you can't simplify it. So you are done.
Wow, yeah, that makes it much easier when you can simplify along the way. But sometimes you can't. Like Salafina's, her problem was just kind of not nice.
There
not,
you go.
very unfriendly.
It was challenging.
I think we do have another caller now.
Challenging. Who's on the line?
Hello?
Hello?
Hello, who is this?
I have another problem.
Salafina? Hey, that's right. If nobody else is calling, you can hog the airwaves. Go for it. What's your next problem?
Well, this time I'm multiplying mixed numbers.
Okay. Give it to me.
The question is 3 2/8
Okay.
times 4 1/4.
Good. Okay, so let's do this fast because you understand how to do this. So 3 2/8 becomes what?
26/8.
Woo-wee, you are a rock star. And 4 1/4 becomes?
Becomes 17/4.
Now, can we simplify it all?
No.
Well, what kind of number? We talked about prime and composite before. Sometimes that's helpful to us. But also, even and odd, right? Yes. So, is 4 a factor of 26?
No.
Yeah, 4 times 6 is 24, 4 times 7 is 28, so that doesn't work. But what number is a factor of both 4 and 26?
2.
2. So 4 divided by 2 is?
It's 2.
Good. And 26 divided by 2 is?
13.
There you go. So we can do that. We are allowed to do that. So that makes that a little bit smaller and a little bit easier to work with. So 8 times 2 is?
Is 16.
Ta-da! Now this one we're going to have to work out. So 17 times 13. 3 times 7?
21. Okay, the 2.
3 times 10?
3.
30 plus 20?
Is 50.
51. 10 times 7?
70.
And 10 times 10?
20.
10 times 10?
10 times 10 is 100.
There you go. And when we add these together, 50 plus 70?
120.
There you go. And then 100 plus 100?
200.
200. Now we have 221 divided by 16. So now we have to figure out how many 16s can we get from 21. I don't like the term goes into. It's not going into, it's sharing.
Because you have to divide, because when it's an improper fraction, you have to divide the denominator into the numerator.
Absolutely, because a fraction is just a division problem.
To make it a mixed number.
Okay, so right now it's an improper fraction. We're going to make it a mixed number. So 221 divided by 16. So how many 16s can we get from that 2?
None.
None. Now we go and take the two numbers together. How many 16s can we get from 22?
1.
So we can take that 22 10s and share it with 16 people. Everyone will get 1, and what will be left over?
6.
There you go. So 12 minus 6, 6. And bring down the 1. So now, what's next?
You have to see how many times 16 can go into 61.
Good. So if I'm estimating, I can bring this down to 15, and 15 2 times is 30. 15 3 times is 45. 15 4 times is,
60.
60. So this is going to be about 16 times. I think 16 times 4 is going to be too much. But that way, instead of going 16 times 2, 16 times 3, 16 times 4, you can estimate by using numbers that you're comfortable with. And you might not be comfortable with 15, but eventually you will be. Are you comfortable with 15?
Yes.
Okay. So 16 times 3 is probably better. So 16 times 3?
6 times 3 is 18. 4.
That work?
Yes.
What about 16 times 4? It's going to be too much, right?
Yes.
64. So we're going to take the 3 minus 48. What's left over?
13.
There you go. So 13, remainder 13. Are you doing remainders in your class?
Yes.
Okay. So as you go up a grade, you'll start to use decimals instead of remainders. But right now, that's good. 13, remainder 13.
I know. So once you divide it, your remainder would be your numerator, and your denominator would stay the same from the improper fraction.
He's making it back in prop. Very good. Very good. So the answer would be, what's 221 16?
Right.
It would be 13 and 13 16.
There you go.
Very
so
good.
13 and that remainder 13 out of 16.
Not very friendly, but accurate. Very good.
Yeah, it sounds like you have some challenging math problems, and you are up to the challenge.
You are. It's just don't let the big numbers fool you or hold you back. It's just a little bit more multiplication, but honestly, you know the rest of it. Very good.
Excelente.
Right. Did you want to try one of our other challenges?
Try another challenge?
Yeah, I wanted to do A now.
You are just racking it up
Here
tonight.
Here it is. Here's A. 8261. Okay, Mr. G. 8261.
8261. Let's go, Rockstar.
Okay. So 6 minus 2 is 4.
Next.
4 minus 1 is 3.
Next.
And 8 times 3 is 24.
Wow.
Excellent job. Excellent. Excellent.
I'm coming to your school.
I know. You're great. I'm putting your name in again. Although it's still all you, girl. It's all you.
Rock.
Thanks for calling.
Rock.
Thank you. Thank you. Listen to you. You're all the kudos.
I'm excited.
You are excited today.
Oh, I think I'm going to Glen Island Woods and hang out over there.
I know.
They're doing some math.
They are doing some math.
They are
Dividing,
doing some math
mixed
at Glen Island
numbers.
Woods.
And she knew how to do it. Wow, I'm very impressed.
I am excited.
Very impressed.
I don't even want to do anymore. I'm so impressed.
You're so impressed. You're just like, wow.
She did 2 challenges.
I know. And got them right.
Got them
on
right.
the first try.
Yeah, like bam, bam. Like, oh, what's
Miss
that?
Harding, was that her teacher's name?
Yes.
What? She is the person to
Miss
see.
Harding is a rock star.
You're a rock star.
When I grow up, I want to teach just like you.
That's right. Excellent. Okay, well, we have a few more minutes left. We do.
I don't even know what to do now.
Come on, we can do some more money.
You like money.
I
Money's a good
like
thing.
money. Money is a good thing. Money, 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 money. Okay, well, let's do, how about we do subtraction and money. So let's say you had...
I like to add money. I don't like to subtract money.
Nope, we're going to subtract it. Let's say you had $6.12.
Okay.
That was your subtotal from your restaurant bill. And my
$6, that's a cheap restaurant.
I know. Well, my subtotal was $4.87.
Woo-wee. Where did we go? To like Dunkin' Donuts?
I don't know, but I want to know what the difference was. How much more did you spend? Because, you know, they told us not to spend a lot of money, and you spent more than I did. So I want to know, how much more did you spend?
Well, if I do front-end estimation and just take the dollars, 6 minus 4 is 2. But we have some coins there.
Yeah.
It's a little bit of coins there, and a lot of coins there.
Yeah.
So it would be less than $2.
Okay.
I spent more, but it's less than $2
Less than
more.
$2 is going to be your estimate. Okay. Well, if I'm comparing, I'm always going to subtract. So if I take your total minus my total, and I line up the decimal points, that's the most important thing, then we can just subtract. But can you do 2 pennies minus 7 pennies?
No, and I think that's what tricks a lot of people. They always take, a lot of people always take the bigger number and take the small number away.
No. If I have 2 pennies, I cannot take away 7 pennies.
Right.
Unless you get a negative number, which you could do this, but that's another whole nother lesson.
What you have to do
So
is
go next
borrow.
Door. Well, who's home next door? In
There's
their
a dime there.
the dime column. So I'm going to
take
the dime away.
Turn it into pennies.
Turn it into 10 pennies.
Now I have 12 pennies.
Now I have 12 pennies.
Now I can subtract 7 pennies.
Yep.
Because I have enough pennies to take away.
So now I have 12 pennies, and I can take away the 7 pennies.
That's the trading part that I don't think a lot of people talk about.
Yeah, it's
They say
easy.
borrow.
Just trade
but
it.
when they
Just give it-
trade, they don't realize that they're changing that from tenths to 100s or from dimes to pennies.
Right. Right now in second grade, we talk about dimes and pennies.
Good.
Dimes and pennies.
Good.
So if
Very
I'm in the
important.
dime column, I have no dimes.
Now you
but
have no dimes.
I need to take away 8 dimes.
But
I
you
have
can take
dollars.
$1.
I could.
You
So I
can
could
take
take a dollar. Now I have $5.
and turn that $1
10
into
dimes.
10 dimes.
Yep.
Yeah.
Yep.
Because
I'm
they're
good.
equivalent.
They're equivalent.
They're equivalent.
Equivalent. 10 dimes, take
10
away
dimes.
8 dimes.
10 dimes
is
take away 8 dimes is
2 dimes.
2 dimes.
Now, don't forget your decimal point. Money always has 2 decimal places.
Mhm.
That's easy. And now I still have some dollars. $5 take away $4.
Okay.
$1.
So I spent $1.25 more than you?
That's not a lot.
So could I borrow $1.25 so I can buy something to drink with
No,
that?
I'm not giving you any more money. I'm the one that was economical that spent less money.
I
But
was a little
you
hungry.
spent
I was a little
$1.25
hungry.
more than I did.
Okay, so you calling me greedy? Is that what you're doing?
Yes, I think you are.
I was just
You're
hungry.
a greedy person.
But you should take that $1.25 that you saved and just let me borrow it so I can get something to drink.
I'm
a little parched.
You're funny. You're funny. Okay, well, so that's how you subtract decimals.
Very good. Very good. Very good. We
That was
did
a good
quite a
problem.
bit with money today.
We did. I love money. But there's also time and money.
Time and money? What
and
do you
money.
mean by time and money?
Well, we were doing we're
Time
doing
is
time
money, money
and
is
money. We were also doing time in fractions.
Time and fractions?
Yep. And I don't think a lot of the older kids go back to this, but just
I'm scared.
understanding that there are 60 minutes in an hour, right?
Ooh.
60 minutes.
That's a
So
little
this
slice of
This
pizza.
whole thing is like
If you
60
took a pizza
minutes.
and broke it up into 60 pieces, that's like, wow.
Yeah, but
You're
half.
just nibbling.
We talk a lot about half. So half is like splitting. So if you have 60 and you're going to split it with 2 people.
Okay.
So 6, well, if you know half of 6, you know half of 60. So a half of an hour
is
30 minutes.
3, or half of 60 is 30.
30 over there and 30 over there. So it's like half the clock.
Gotcha.
So you have to know your fractions before you can do time. Because if you know
Do
fractions,
you have to know your fractions before you can do time?
I think it's helpful.
Okay.
But you don't have to. Haha, get
Because
it?
now you can just read the numbers and they're just like, I don't know, it was 4:57.
Right. Yeah, they don't. But if you use an analog clock, it would be helpful to know that when the minute hand has gone to the 6, halfway around, it's half past an hour. So that would be something 30. It'd be 30 minutes. 3, 34, 35, 36, 30. You have to know that. Yeah.
Well, see, this is a little different because now half is 30.
Right.
Any other time we're talking about half, we're talking about.
But money, when you're talking about money,
There
half
you go.
isn't 30.
That's a little confusing.
When you're talking about a dollar, the whole dollar is 100 cents, and then half of that would be 50 and 50. So yeah, you're right. Half has a different number amount based on what you're talking about, your context.
Absolutely.
50-50,
Absolutely.
30-30, doesn't matter.
I like that. Can you break that clock up into 4 equal parts?
Sure you can. You can do that. 4 equal parts. Oh, that's where people call it quarters. A quarter past, a quarter to. So if I break it up into 4 pieces, 4 quarters, 25, 25, 25, and 25. That's 4 quarters is a dollar. That's why we call it
that's
quarter.
why quarter past.
But it's not like that on a clock.
Right.
That's for money.
That's why
We get the name quarter because quart means 4. But on a clock, when you split 60 into 4 pieces, it's not 25, 25, 25, and 25. That'd be a dollar. That'd be 100. There's not 100 minutes. So we have to do it
That's what
differently.
makes it confusing.
This is what you were talking about, your 15s. So 15, 15, 15, 15, and
So that's
15.
why 15 after the hour is a quarter past.
That's right, a quarter past. And that's why when you go over here, 45.
It's quarter to.
Quarter till, quarter of.
Because it's a quarter of the 60.
That's right, a quarter of the way around, a quarter of it.
I got it.
Yeah,
Four
but you
equal
still
parts of the
have to
60.
know what you're talking about. Time is out of 60
Right,
minutes. Dollars, or money, is out of
Gotcha.
100.
That
Yeah.
makes so much sense. So it is
It
helpful
does
to
make
know
sense.
fractions when you're talking about time.
I know, but our time is up. Speaking of
No!
that. Yes!
Oh, it's fun math.
And I'll let you pick anyway.
I think, I wonder who's going to win.
Come on. Pick the name out, Mr. G.
Oh my goodness, it's Salafina! She won for Planet Woods! I don't believe it! Oh!
Congratulations! Congratulations!
Incredible! She
So
pulled it
excited.
off!
She pulled it off!
You're going to the Olympics!
It was a photo finish, but she pulled it off.
Yeah.
Thanks for calling, Salafina, and everybody else out there. I know you were watching, just doing your own homework. And remember, from all of us, you can always count on us.
My name is Mrs. Sun, and I'm here with today's mini lesson on area. Very often people learn about perimeter and area at the same time, so I want to talk to you about what area is and the difference between the two. Our objective today is to apply measurement concepts in order to determine area. Area is the number of square units inside a shape. So we are looking at the inside of a shape. So very often you're going to look for keywords in word problems. Sometimes people are talking about finding carpet for a room or tile for a floor. Look for those keywords where the word problem is talking about covering the inside of a shape, because often they won't say find the area. They will say how much carpet is needed, or how much tile is needed, or how much paper to cover. That would be another keyword, a bulletin board. So look for those keywords, and we're going to talk about how to find area in a moment. There are a few different ways. Let's take a look at word problem number 1. Melanie wants new carpeting. There we go. There's that keyword for her family room. Her family room is 8 feet by 4 feet. How much carpeting does she need to cover the room? Anytime there's a word problem and you don't see the shape, go ahead and draw that shape. So I'm going to draw a rectangle here. It's not going to be the prettiest rectangle, but it's going to work. And we're going to label that. We know it is 8 feet by 4 feet. Now, in order to find the square units inside, we often multiply to find the area, and that will work, but I want to explain why that works. When we are multiplying to find the area, 8 times 4, what we're doing is 8 groups of 4. So what we're really doing is we're really building an array inside of this shape. So we would break this up into 8 groups. Okay, that's 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. They're not equal, but pretend they are. And then here we would have 4 groups. So what we are doing when we are multiplying is we are building rows and columns of equal groups to build an array for 8 times 4. So if we counted that out, we would know that that would equal 32 square units. Since we know it's feet, that's 32 square feet. Anytime we're talking about area, we want to talk about the square units because we are building those square units inside of a shape when we multiply. So to find the area of a rectangle or a square, I want you to multiply, but the reason is you are building that array inside. If you are finding perimeter, I want to talk real quickly about the difference. Perimeter would be the distance around. So it would be 8 plus 4 plus another 8 over here plus another 4 over there. But that's another mini lesson for another day. Let's take a look at one other problem. I really like this problem. This is from mdk12.org. Nathan divided his rectangular garden into 8 sections that are the same size and shape. What is the area of the whole shape? So this side right here says 4 feet, and this says 7 feet. So there are a few different things we could do. If we want to multiply length times width, we could find the length and the width of the whole thing. If this section is 4 feet, this section is 4 feet, so this whole thing would be 8 feet. If this is 7, and we know that this is a rectangle, then this is 7, and this is 7. So this whole thing would be 14 feet. So we found the whole length and the whole width by using what we know about these rectangles right here. So we could multiply the length times the width, 14 times 8. 8 times 4 is 32. 8 times 1 is 8. Plus 3 more is 11. So it would be 112, remember, square feet. Okay? Now, we could also find the area of this rectangle right here by doing this rectangle right here would be 4 times 7, because that's the length times width, which is 28, and then 4 of these exact rectangles. So 28 times 4 would be 8, and 3 more would get you the same answer, okay, square feet. But I like to find the length and the width of the whole rectangle. Otherwise, be careful, because 7 times 4, 28, was the area of this whole rectangle, and that whole rectangle happens 4 times. So be very careful of word problems, but remember, for rectangles and square, length times width. If you're not sure, you can always remember ma and pa, multiply area, perimeter, add. That will help you remember the difference. So, my name is Mrs. Sun. That was today's mini lesson on area, and I hope you have a wonderful day.
Minds can achieve anything. We make sure they get to college. Federal student aid provides more than $150 billion in grants, loans, and work-study funds to make college possible for anyone with the mind to get there. Because if given the chance, minds will do great things. Federal Student Aid, proud sponsor of the American Mind. Learn more about money for college at studentaid.gov.
Because how many ways are there to solve math? Many!
Your live home help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel? All right, so let's add 3 here and see what happens.
First, I need you to double check yourself. So the second equation for solving perimeter is
2 times length plus 2 times width.
Good evening, everyone out there. Welcome back to the second half of our show, Count on Us. My name is Mr. Pugh. I'm here with my co-host,
Ted Herman. We're here to answer every question you ever had on your mind about mathematics, because we're getting ready for the big test in March, MSA.
In about 2 weeks, it's reading, and a week after that, it's math.
And what's our number here, Mr. Pugh? 301?
702.
779?
I think it was 0080. Is it 772-0080?
There you go. Or you can go to the World Wide Web and watch us mess this up. The World Wide Web, www.pgcps.org, and scroll on down till you see a podcast and follow us there on the computer. But whatever you do, turn those TV sets all the way down so you can hear us and we can hear you better. And
you know what? I was so distracted because I'm so excited that my audio-visual person, Naja Brown, she finally spoke to me today.
Where is she?
Hi, Naja.
Where is she?
Hope she called in the show today.
Oh, she's back behind us in the booth.
She's behind us in the back.
She's running the show.
She's right behind this sign right here.
Right there?
All right.
I can almost
see. So let's go to our two
let's go to our challenges.
Our challenges for today.
Besides me trying to talk today, our challenge is right here on the screen. Okay? So
I've been away for so long. I miss you, Ted.
I miss you too, Mr. Pugh.
Mr. Herman.
You delight my life so much. This is called the 24 Challenge. You want to explain to the students out there?
Of course.
Oh my goodness.
All right, people in TV land, this is Challenge 24. When you called in the show and answer a question or ask a question, you are able to do a challenge. You use A, B, C, or D. Remember, you must use each digit in the project. You can use any operation you like in order to solve the problem. Your final answer / solution must be 24. So remember, these are 9s. When it's shaded in, those are 9s. When it's not shaded, it's a 6. So when we ask you to write the digits down before calling in the show, and please have them worked out before you ask for Challenge 24. And if we show them to you again, you can write them down, and you can call us back if you've not written them down beforehand.
and we can say this is a 9485. So you're writing that down. And you want to do B, Mr. Pugh? Do you want to do that one?
Of course, Mr. Herman. 3387. I feel like that.
Oh,
right.
very well disguised. I mean, it's discussed. And 7824.
I'm assuming I'm going to do the last one?
I think you should.
And remember, folks, the dots on the corners let you know, indicate how tough it is. 3 dots means it's really tough. It's really it's real challenging. So it's 7347. And we have a second challenge of the day. It's the word scramble. The word scramble today, you may call in and ask yes or no questions, and you may take a guess. And remember, the more you get right, or the more challenges you solve, the more chances you get to get your to win that prize at the end of the show. Remember, your name going inside the treasure chest.
So what we got to do is unscramble those letters and make a mathematical word out of
What
it.
did I say?
I think you did.
Thank you so much.
Nobody has it on tape, do they? Can't play it back and show us what you
People
said.
in our ear talking to us right now.
So this is a mathematical word. I'll give you a hint. It has something to do with math, okay?
Something to do with math?
Yeah. No.
Math.
Not big enough. Yeah,
Numbers.
It's the word. It's the word. Oh, give me a chance to say something in front of everybody.
Go ahead.
If I get my face on the TV again real fast, I'm going to do an old song from the 50s or 60s. It's the.
He wants a close-up.
It's the word. Okay. It's the word of the day. Word scramble. It's called.
There you go.
Word. That's it. That's all I got. Nothing else. Okay, we'll go to our first caller, I think, right? The word. That's all that.
Oh, let's go to our first caller.
Okay, that was bad. That was bad.
That was hilarious, Mr. Herman.
That was sad. I'm sorry.
That was hilarious.
Caller. I brought the show down to a low level.
Are you there, caller?
Hello.
Hello, how you doing?
Good.
What is your name?
Salafina.
Salafina, that's a nice name, Salafina.
Salafina, one of our regular
and
callers.
what school do you go to, Miss Salafina?
Calls all the time.
Glenarden Wood.
All right.
I got
Okay.
it. I got it. Sure.
And Salafina, how can I help you this evening?
Well, I'm dividing mixed numbers.
You dividing mixed numbers?
Yeah.
So you have a problem you want to talk about?
Yes.
What's your problem?
My problem is 3 1/7
I like how you say that. 3 1/7
divided by 7 4/7.
Oh my Lord! I like that, Salafina. So I'm asking you this question. Can you tell me what I'm about to do first?
Excuse me?
Do you know what you're supposed to do first?
Huh?
What's the first step into solving this problem?
Oh, you have to change the mixed numbers into improper fractions.
So can you help me out with the first one? 3 1/7. Change that to a mixed improper fraction, please.
3 1/7 changes to 22/7.
Oh my Lord! And I'm gonna tell you, you must multiply 3 times 7, added to 1, correct?
Yes.
You got 22, and your denominator always remain the same. Great job. All right, what's the 7 4/7 change to improper fraction as?
53/7.
Oh my, 53/7. So I'm asking this question, Sarah Lafina. Can I divide fractions?
Yes.
You can divide fractions? Tell me how.
Oh, no.
Okay, why not?
Because,
Because fractions are already division problems, correct? Correct?
yes.
Now, I always told my students this when I teach this to my students. It's like I was trying to integrate it with language arts because they teach you not to speak in a double negative, like no, not me. Because you can't say no, not me. That don't make any sense, a double negative. And fractions is the same thing. You cannot divide fractions because they already division problems. So what must I do when you have to divide fractions? Do you know?
Well,
You know that big R word? I can't pronounce it sometimes.
Reciprocal.
Oh my grace. Can you say it again, please?
Reciprocal.
Oh my goodness, it's the reciprocal. What does reciprocal mean?
The reciprocal means to make the denominator the numerator, and to change the numerator to make the numerator the denominator.
Now, in order for me to use the reciprocal, what must I do with my operation?
Well, then you have to change the division sign to a multiplication sign.
Now, what grade are you in?
I'm in 4th grade.
Okay, so I'm not going to use no big words for you, no fancy words we use in middle school, like, hey, we use the inverse of division. You be like, what? What is inverse? I don't never heard of that word before, but it's inverse, which means opposite, undo, correct? So I'm going to do what you said do. So I'm going to keep my first fraction the same, 22 over 7. So I'm going to flip my, you said flip my operation to multiply and use my reciprocal, which is 7 over 53. Now, can I ask you a question?
Yes.
Are you good with are you really good with your factors?
Yes.
Okay, so let's look at the problem again.
You can simplify before you multiply.
Oh my God, she did vocabulary she's using?
She's incredible.
So let me know, what can I simplify?
The 7 in 7/53 and the 7 in 22.
So I can cross cancel. So 7 going to 7 how many times?
You make the 2 7s a 1.
Oh my gosh.
Because they're both factors of each other.
Oh. So now can I cross multiply now?
She's golden.
So what's 22 times 1?
22 times 1 is 22.
And what's 1 times 53?
1 times 53 is 53.
And so 3 and 1 7ths divided by 7 and 4 7ths is equal to 22 53rds. You got that?
Yeah.
Any questions?
Can that be simplified? I don't know.
Can that be simplified?
No.
Great job.
Good job.
Did you have another question?
Huh?
Did you have another question?
Yes.
Oh, what's your question? I'm here for you. I'm your personal tutor right now for the next hour. What do you need, Mr. Herman? What do you need?
He's had the longest close-up in history, I swear. Excuse me, I didn't mean
I had another dividing mixed
Thank you.
numbers question.
Go ahead. What's your question?
Who did that?
Okay. Well, this one was easier. It was 2 1/2 divided by 6 and 1 6.
6 and 1 6?
Uh-huh.
So now let me break it down a little bit more for people in the TV land who's watching this, for the same kids in your grade level, okay? So I'll take my whole number and multiply by my denominator, which is 2. So that's telling me 2 times 2, it gives me what? 4, right? So I'm going to add my numerator, which is 1, get 5. So I got 5 over 2. We all know my 2 is my denominator. Must stay the same. I'm about to do the same thing on the other one, which gives me 36 plus 1 gives me 37. So 37 6. How you saying that? So once again, here we talk about inverse means opposite or undo. So I'm going to take my 5 halves, inverse operation divisions, multiply, use my reciprocal, your word you used earlier, and got 6 over 37. Oh my goodness, 6 and 2 have a common factor of 2. That gives me 1, that gives me 3. What's 5 times 3?
15.
I'm faster than you. What's 1 times 37? 37. I beat you. Can I be simplified? No. Pretty good. And there you go again, okay?
So the answer is 1537.
Yes.
Cellophana's a doll. She's
so
wonderful.
Seraphina, what I'm gonna do now, Seraphina, I have a challenge for you. I have a question for you, Seraphina. I want you to look at the screen again. Select one of these, A, B, C, or D. Pick one right now, and write the digits down. Which one you want?
I have an answer to D.
To D?
Yeah, the hardest one.
You already worked it out already?
Yes.
Whoa.
Oh, my gracious. Oh, okay. Hey, you getting all the TV time today. Okay.
Come on, bring it on.
We can go 7, 7, 4, 3. Talk to me.
I'm writing her name.
Okay, so 7 times 4 is 28.
7 times 4 is 28. Yes, ma'am.
And 28 minus 7 is 21.
Yes, Go ahead.
And 21 plus 3 is 24.
Give her the bell, babe!
Bing-a-ling-a-ling-a, bing-a-ling-a. Bird, bird, bird. Bird.
Good job, Seraphina.
Seraphina.
You're an awesome student. You're an awesome student.
She is the best.
And remember, you get to middle school,
wonderful.
look for me. Come to my classroom. Make my job a lot easier.
Nice job, Seraphina.
And so continue to watch the show at the end to see if you won our prize at the end, okay?
Huh?
Continue to watch the show at the end of the show.
Okay.
To see if you won our prize at the end, okay?
Okay.
Bye-bye.
Seraphina's already a prize. She's a gem.
Wow.
She knows her stuff. Doesn't she know her stuff?
Great
She's got
first
some
call.
good teachers
Great
over there. She's
first
learning
call.
her stuff right.
Want to do the next one?
Next caller, I would like to be part of the show now. Is that Ola Wasson? How do you say your name? I'm not sure. Hello?
Yes.
Hi, what's your name?
Oluwaseun.
Ola Wasson. Oh, very cool. What school you at?
I had a question about coordinate planes.
About what?
Coordinate planes.
Aren't you at Glen Arden Woods?
Yes.
Very nice. What grade are you in, Ola Wasson? What grade are you in?
4.
Fourth. Are you in the same class with Celafina?
Yes.
Fantastic.
Okay.
Well, coordinate planes. I'll take this one. That's when you have these big planes take off the airport.
747.
And they coordinate, and they go out in space, and they go up in the moon, right?
No, not those.
Oh, not those? Okay. Must be the other smaller ones.
Oh, coordinate planes like an XY axis, no XY, and you're doing coordinates and you're trying to find the points on the plane. Oh, well, I think that's going to be fun. What do you got there?
Well, I have to find some ordered pairs on a coordinate plane.
Okay. Do you want to give us the ordered pairs, and then we'll find the plane? Don't miss the boat. That's going down in flames. My plane is going down. Okay, let's go ahead. Olawaswan, give me your first coordinate pair.
My first coordinate pair is 5 and 0.
5, 0. That's a great number. 5, 0. And you know what? This is great. I love coordinate planes. Did you ever hear a thing about a thing called GPS? GPS has global positioning satellites.
I know that.
And that's how we find our way around town. So sometimes these cars, I don't know if you've been in one of these cars, or even your cell phone or whatever you're working with, can give you an actual map and show you how to get around. It's all based on coordinate points. That's great. Good job. What's your next pair?
5 and 1.
5, 1. Okay. Be careful when you ask for a close-up, because some people just love to get that close-up, and I'm getting embarrassed now. 5, 1. What's your next pair?
5, 2.
5, 2. So we got 5, 0. I'm starting to see a pattern here. 5, 1, 5, 2. And any more?
5, 3.
I had a feeling. I've got a feeling.
I was thinking the same thing.
Oh, my goodness. We think alike. And how about 5, 4? You got 5, 4?
Yes, that's it.
That's it? 5, 4? That's it. That's wonderful. You're terrific. Are you a first-time caller?
Oh, no, there's no... This is my first time calling.
Oh, okay. But what happened? I did too many points?
No.
5, 4 is
No.
okay? Is 5, 4 in or out?
Oh, there's no 5, 4.
There is no 5, 4. Okay. I got a little carried away. Okay. Well, the coordinate plane should look like this. And we'll put our X there and our Y there. And I hope you know one thing. How do you say your name again? Olawaswong?
Olawasong.
Olawasong? X, Y. Now, here's what I tell my students. As Mr. Pugh beautifully puts the arrows on to show it goes on and on to infinity and beyond. Well, here's what I tell my students, Olawaswong, is that when you go to a hotel, you go to a hotel to visit a friend, where do you have to go first when you come through the front door?
Origin.
You go where?
Origin.
Oh my goodness, the origin. She knows about origin. Very good. Where is the origin? What point is that? 0 what?
5.
Well, I mean 0, 0. 0, 0. Okay? That's the origin. That's where we're going to start. And what I tell my students in class is like this. If you go see somebody in a hotel, hi, good to see you back. If you go see somebody in a hotel room and you want to go visit them, you have to go across the lobby first and then up and down the what? Elevator. That's close enough. I'll take your answer too. Up and down the elevator. So first we always go across, and going across is the x-axis. Then we go
the x-axis first, and then the y-axis.
I love it. Another way to remember it too is which comes first in the alphabet, X or Y?
X.
X. So we always go across the lobby first, up the elevator second. So we're going to go across how many the first time?
5.
5. So 1, 2, 3, 4, 5. I think I'm going to change pen color just to give it more of a flare, and you can see the dots better. Can I buy that blue or red or something? Oh, red. Oh, beautiful. 1, 2, 3, 4, 5. That's the 5. Wait a minute. How come I stayed right in the line?
Because you don't move any spaces because 0 means nothing.
Right, 0 means nothing. Don't go up on the Y. Stay right on that line. Now, tell me how to get from 5, 1. How do you do 5, 1?
You start at the origin.
I love that.
You move 5 spaces on the x-axis. Then you go up 1 space.
You are terrific. You really know your stuff. X-axis, she said. You hear that, Mr. Pugh?
I guess I did.
That's great. And then what we're going to do now, we have those two coordinate pairs lined up and plotted. So what are we going to do now?
Then 5, 2.
So tell me how to do that.
Start at the origin, move 5 spaces on the x-axis to the left, and go up
to
2
the what?
spaces.
To the right?
To the yeah, right.
Okay.
And then you go up 2 spaces.
2 spaces up. Very good. And then one more.
And then 5, 3. You start at the origin. You move to the right 5 spaces and go up 3 spaces.
I love your style. And then we have to connect them all. Can I see that blue pen for
Oh,
you?
yes, for sure.
Oh, you're great. You're wonderful. So I'm going to do a line. Hey, what kind of line is that? Is that horizontal or vertical or diagonal or what?
It's a vertical line.
Vertical line.
Like the y-axis.
Oh, my, just like the y-axis. How brilliant. In other words, they'd be parallel, weren't they?
Yes.
Yeah. And that would be the way you would plot that. Okay? And if you get to algebra in a few years, or maybe you're already getting there, you would have an equation like this. X equals 5. Because every one of your x coordinates, oops, somebody erased it. I guess it was my hand. But x, every value on the x was 5. So you go over 5 no matter what you have. And you get a vertical line out of that. That was terrific, Olawaswan. Okay? And you want to try a challenge too?
Yes, challenge card.
Because you got your name in. Oh my goodness, he has your name already beautifully printed up from Glen Arden Woods. And you're going right into our treasure chest. And did you want to try the word of the day?
Or the 24 challenge?
I like the D card. Card D.
Okay, so which one you like to try, Olawaswan?
Card D.
D as in dog and David Dag?
I'll write those down.
Okay,
3774. And you want to take over, Mr. Pugh, because you're so
you
good.
You want to do it?
Well, no, I'll do it. Sure, I'll do it.
It's
I'll do it. I'm a little nervous about this. I don't want to let her down anyway, because she's
you
so
have to,
sharp.
the same way. You won't have to.
So 7 minus 3 equals 4.
Hold on, let me see what I'm doing here. 7 minus 3 equals 4. Okay.
And then 7 times 4 equals 28.
This 7 and that 4?
Yeah.
Okay.
Yeah.
This 7 and that 4?
Mm-hmm.
You're using those?
28.
Mm-hmm. Mm-hmm.
Wait a minute. I'm lost. There's a 4 here.
Yeah, she's going to use it later on.
Oh, okay. So don't use this 4 yet.
No, she's going to use that 4.
Use that 4. 7 times 4 equals 28.
Go ahead. What you do next?
Oh, I got it.
And then 28 minus 4 equals 24.
Oh.
Good job.
Oh, my goodness.
Good job.
Oh, She got, geez, right in my ear. Nice job. I got it because she was playing the 24 challenge. I was playing the 28 challenge. That's great. Does her name go in twice?
Yes,
oh
it goes
my
in
goodness!
twice.
I'm gonna write it up right now. All of us won't, and you did a great job. Call anytime. Just make sure you get Mr. Pugh. Okay?
Make sure you continue to watch the show at the end. Make sure you continue to watch the show at the end. Otherwise, I want to see you win our prize. Okay?
Okay.
Thank you.
Her name. Nice job. First time caller. Do you believe how smart she is?
Kadika, we're going to get to you right after we come after my commercial break. We need to take our commercial break at this time. We'll see you after the break.
Good.
Hello, my name is Shayla Tucker from Stephen Decatur Middle School from 6th grade. I'm here with your email corner for today. Here's our problem. Judy has 8 candy bars. She wants to give 1/3 of a candy bar to everyone in her class. Does she have enough for all 24 students? We already have our diagram divided into 3 pieces, so now we can count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we have 24 pieces. And now for our numerical expression, we have the total of candy bars, which is 8, divided by the parts that are shared, which is 1/3. So we make our fraction, which is 8 divided by 1/3. Now we have to find the reciprocal, and we have to change 8 to 8 over 1 because we have to make this a fraction, times 3 over 1 because that's our reciprocal, which equals 8 times 3, which is 24, and 1 times 1 is 1. So our solution is she has enough for all 24 students to have a piece. My name is Shayla from Stephen Decatur Middle School with our email corner for today. See you next time.
Can you tell?
Can you tell?
Does it look like I'm fighting a disease?
Fighting.
Fighting.
Fighting for my life?
Like my life expectancy is shorter than yours?
There's no outward sign.
But we're battling every day.
Every day.
Every day.
Worrying, testing,
Treating.
Fighting. Fighting. Diabetes.
Diabetes has been called a silent epidemic. It's time to call it out for what it is. This is Brett Michaels. Join us. Choose to share, act, learn, and give. Help us stop diabetes.
When I was a kid, I dreamed of being a stuntman.
I went from dream to dream pretty quickly.
I wanted to be a cowboy.
Tom Cruise in Top Gun.
I dreamt of being a nun.
Actually, before that, it was Popeye.
Malaria kills more than 2,000 children a day.
Text NET, N-E-T, to 85944 to make a $10 donation to Malaria No More.
Oh, messaging and data rates may apply.
Let's make malaria no more.
Welcome back to the second half of Count on Us. Once again, my name is Mr. Pugh.
I'm Ted Herman. We're here to answer all your math questions today. We've had a lot of great callers who are so wonderful in Prince George's County school system.
And remember, every Monday and Wednesday from 4 to 6, 4 to 5 is an elementary show, 5 to 6 is a secondary show. We're here to answer any questions you might have, especially when all the big testing is coming up. MSA, HSA has been passed already, but you know you'll take the, another test in science in a few weeks. It's math and science are like cousins, so those formulas, those chemicals, all those things, come on,
right.
we work with you. Expressions, we can work with you. So once again, we get back to our show. We have a few callers waiting. You want to go back?
Do we want to review the challenge
Yes,
again one more time? I think we ought to do that.
All right.
Let's go look at the challenges.
Remember, we have the Challenge 24. As you all know, you must, in order to answer one of these Challenge 24, you must call in with a question. And as we ask you all the time, like the first 2 callers did so far, I have it already pre-written out or worked out before you call the show. So write them down now. You call in, you want to try a challenge, write it down now. And remember, that is a 9. That is a 9. And letter D has been solved twice already.
Different ways, right?
Different ways.
Okay.
The best thing about math is there are multiple ways to come up to an answer. So
True.
as long as you give us a different way, we accept your challenge. We also have
a word of the day, and this word has something to do with math. And since nobody's even attempted the word, I'll tell you one thing. It has something to do with algebra. That's all I can say. Algebra.
Oh, right, algebra. And math, right?
Math.
Okay, good.
Math algebra.
All right, math algebra.
As opposed to zoology algebra.
I don't know. It could be algebra because ooh. Okay, let's continue. Let's continue. Let's go to the next call. Want me to take it?
I think you ought to take it because I'm worn out from the last time.
Good job, Aluwasun. Caller, are you there?
Hello?
Hello? Is this Khadija?
Khadijah.
Khadijah. I'm sorry. How you doing, Khadijah?
Good.
What school do you attend?
Dividing fractions.
Okay, dividing fractions. That's a nice school. Also, you need help with dividing fractions, so give me your problem.
Is that in our county?
I think it's Kettering Middle School.
I think I bypassed it one day.
So what's your question? What's your question, Khadijah?
8.
8.
Divided by 2 6/3.
2 6/3?
Yes.
So is the problem correct on the paper?
Yes.
So I'm asking you a question, Khadijah. What must I do first?
Change the improper fraction. Change the mixed number to an improper fraction.
I love the way you self-corrected yourself.
Oh, that was very nice.
Can you tell me how to change my mixed? I'm going to say the same thing. My mixed number to improper fraction. So what do I do
Say that
first?
again?
How can I change my mixed number into improper fraction?
Multiply the denominator times the whole number plus the numerator.
Great. So that gives me 8 divided by what? 12/3?
36/3.
How you get 36? Talk to me.
3 times 2 is 6.
Okay.
Oh, never mind.
Oh, so I'm right? Am I right?
Yeah.
Okay, let me shake it up a little bit. I'm shaking it a little bit. Hey. Okay, let's go. Good. So that becomes 12/3. What I do next?
Find the reciprocal.
What's my reciprocal?
Where's the overhead shot?
8/1 times 3/12.
Oh, so I love you put 8/1. And you said times 3/12. Good job. You also changed the operation. Great job. So what I do next? Let me know what I do next.
8 times 3.
Okay, so you want to work it out long ways. What's 8 times 3?
24.
Okay. Over?
1 times 12.
Which is?
12.
And what's 24 over 12?
You have to simplify it.
And which is what?
It would be...
Say that number again?
It would...
What's that number you just said?
Divided by 12. It would be 2/1.
2/1, which is equal just to 2, correct?
Yes.
So 8 divided by 2 6/3 is equal to 2. However, I'm going to show you something. If you know, one thing we talked about in the last call about understanding our factors. I know 8 and 12 are even numbers, so they don't have a common factor of 2 or greater common factor of 4. So I know 4 going to 8 2 times. I know 4 going to 12 3 times. So I know 2 times 3 gives me 6 over 3, and 6 divided by 3 gives me 2. These are much smaller numbers than those big numbers.
You cut a lot of steps out.
Yeah. But, Khadijah, do you understand what I just did and showed you?
Yes.
Great job. Thank you for walking me through that problem. You did an excellent job. And your name is going in the treasure chest. Can I
do a challenge?
I was about to ask you, do you want to try a challenge? Which one you want to try?
The 24 challenge.
Of course. You can do a challenge, Khadijah. So which one would you like to try? A, B, C, or D?
B.
B as in boy?
Yes.
Okay, here we go. 3, 3, 7, 8. So 3, 3, 7, 8. Tell me what to do.
3 times 3 equals 9.
3 times 3 equals 9. Yes.
9 plus 8 is 17.
9 plus 8 equals 17. Yes.
And 17 plus 7 equals 24.
And 17 plus 7 equals...
Bingo!
You get the crazy arms. You get the crazy arms. The crazy arms. Great job, Khadijah. Your name going out not once, but twice.
Another time.
Good job. And continue to watch the show at the end to see if you win our prize, okay?
That box is filling up.
Great questions. Good job. We have some excellent callers tonight.
We have some very smart,
What is
talented
going
people out
on?
there in the land.
That lets you know our teachers out there doing a wonderful job with you guys. Great job, teachers.
I love it.
Great job, teachers.
Parents, teachers, students, everybody.
Great job.
Making a team effort together.
Yes.
Beautiful. Next caller is Amaya. Hello?
Hello?
Hi, what's your name?
Amaya.
Amaya.
Good job, Mr. Hearn.
Are you at Fort Foot?
Huh?
Are you at Fort Foot?
Yes.
Is that close to High Ankle? Fort Foot? No, that wasn't it. Okay, what's your problem today, Amaya?
What's my problem?
I mean, do you have a math problem? I don't want to get started with your personal life, but do you have a problem in math?
She's confused right now, Mr. Hearn.
She said, "What's my problem?" I thought maybe I offended her or something. I'm sorry. What's your mathematical problem? Question.
Expression.
A question?
My question is, I need help on expression.
Oh, like "what's up"? One of those expressions, like what's happening?
How you doing?
How you doing?
How was your day?
Or hi.
Hi, hello.
Hello.
See.
Hi.
Hi.
Okay.
Okay, what's your expression in math? Is it, I guess, algebra of some sort?
Algebra.
Okay. Do you want to tell us the expression, please?
8 to the 4th power minus 3 times 10.
8 to the 4th power minus 3 times 10.
Did you want to write that? Because you have better handwriting from that.
You said A to the 4th power?
Yes.
A to the 4th power minus 3 times 10.
Yes.
Oh, can I go over that a little fast? Thank you, Mr. Pugh. That was really well written down. A to the 4th power minus 3 times 10. I know Mr. Pugh was ready to chomp on that problem because he knows his stuff. He teaches middle school, don't you, or high school? Okay. Anyway, how about this, Amaya? Please excuse my dear Aunt Sally. You ever seen that?
Yes.
You have? And that's called order of operations. So what's the P stand for? It doesn't really stand for please. It stands for what?
Parentheses.
You're sharp. And E?
Exponents.
Exponents.
Exponents. There you go.
Excellent.
That's it.
You must have heard a voice from above. Came right in your ear. And what's the M?
Multiply.
Yes. And then D?
Divide.
Yes. I'm going to put like a box around those because they are both equal to each other, but the way you work order of operation from what direction? Left to
right.
To right. Nice job. So if multiplication and division are in the same row or same expression, you would just work whatever came left to right first. Okay, it doesn't mean multiplication is more powerful. And then A stands for
Addition.
and S stands for
Subtraction.
You know, I cannot work under these circumstances. There's so many things flying past my ears while I'm trying to explain this problem. I never bother anybody when they're doing their problems, so I'm just trying to stay with it. So let's do this together, Amaya. What would you do first? Is there any parentheses in this problem? Are there any parentheses on this problem? No, there are not. So let's go to the next thing, which is exponents. Exponents. Where's the exponent?
Yes.
A to the 4th.
Fourth power.
Fourth power. Outstanding, Amaya. The only trouble with that is, what is A? Is it a number or a V word we know about? There's no number there, so what's that V that stands for A?
A V.
A V,
Variable.
right. A variable. So I heard it. I heard it. Give it up for Amaya. Yeah, she knows her stuff. She knows her algebra. Variable takes the place of a number. The only trouble with this variable is we can't get a true number for an answer out of this. All we can do is keep the A to the fourth just the way we found it. However, I'm going to skip the subtraction sign. You know why? Because subtraction is all the way down here. What's that symbol right there? That dot.
Multiplication.
Right, and that's higher and more controlled. So I'm going to do this first. We're going to do the multiplication part first. What's 3 times 10, Amaya?
30.
Nice job. So then we come back and put the subtraction sign. And that's about as far as we can go. Why is that, Amaya? Why can't we go any further than that?
Because the A is a variable.
I love your style. And here's what I tell all my students in algebra class. Make sure when you're doing algebra steps, you make sure you go far enough. But don't go too far. Because if you go too far, then you've gone too far and you've ruined the whole problem. You might make the answer all mixed up and bad. So this is our stopping point. A to the fourth minus 30 is as far as we can go. And that's about enough for the close-up because my teeth are still not doing too well. Oh, my goodness. That is great, Maya. And she getting her name in the box, the treasure chest?
Yes.
You want to try, he's already got it written out from foot, right below the ankle. And let's go ahead and do you want to try a challenge, Maya? Like a 24 challenge or a word of the day? What? I'm sorry, I couldn't hear you.
I want to do B.
B. I guess that means the 24 challenge B.
3378.
3378. You're terrific. What a co-star. 3378.
No, you the star.
No, you're the star. I'm just the co.
He's the man.
No, he's the star. 3378. What's your first step, Amaya?
Natasha Brown's the star.
3 times 7.
3 times 7? Okay, what does that give you? What's 3 times 7?
21.
We're doing a problem here. Nice job, Amaya. And what do you do next?
Plus 3.
Plus 3? Uh-oh. Uh-oh, because now I think you might be locked. You still haven't used the 8. And I don't know what you're going to do about that. You already got your 24.
3 times 8.
No, you can't do that. That's illegal. You've already used the 3s up, Amaya. So copy those 4 numbers down and call back as fast as you can.
Can I do another? Can I do another one?
Yeah, if you call back, because we have a lot of people waiting on the line. But copy any numbers down you want and then call back as soon. We have plenty of time on the show to call back, okay? But thanks for calling. I don't know if she's a first-time caller or not, but she was great. And you know what? Cellophana's back for you, Mr. Pugh.
You sure she's for me?
Cellophana's for you. I can tell she has that link up with you. She loves talking to Mr. Pugh.
Celophana.
Hello.
How you doing?
Good.
You have another question?
Yes.
What's your question?
Okay. My question is 5 1/4.
Oh, another mixed number? Okay, 5 1/4.
Divided by 6 and 3/8. Yeah.
Celophana?
Yes.
Can you do me one favor?
I'll turn off my TV.
You don't got to turn it off. We can just
I'll turn it down.
Just turn it down. Because guess what? When I talk, I hear myself talking.
Okay.
I don't like the way I sound.
I turned it down.
Thank you, Celophana. All right. So now, Celophana, I know it's a TV show. You're going to be the star today. I'm not going to say one word after this point. I want you to tell me what to do, okay?
Okay.
I'm quiet. I'm quiet for the next, I give you 2-3 minutes. I'm quiet for 2 minutes.
Okay. So you have to change. You have to change 5 1/4 to 21/4 and put a division sign. 21/4 divided by 51/8. And then you put 21/4 times 8/51. And you change the 4 to a 1 and the 8 to a 2. And then you multiply that. And you make 20, and then you multiply numerator times numerator, denominator times denominator. So 21 times 2 is 42. You make 42 the numerator in your product. And the denominator is 51. Because 1 times 51 is 51.
Are you finished?
Yes.
Now I have a question for you, okay, Serafina? This problem is a little bit more challenging. Look at 21 and 51.
Oh.
Look at 21 and 51. Do they have a common factor?
Oh, yeah.
Which is?
It's 3.
Oh, yes, it is 3. I said I wasn't going to say anything, but I want you to challenge yourself a little further, okay? I know it looks kind of big numbers and we don't like looking at that, but guess what? Look at ourselves. 21 is 3. So 3 going to 21 how many times?
7.
And going to 51 how many times?
17.
So now I guess that really gives me what? 14 over what? 17.
It'll be 14, 17.
Outstanding.
Serafina, I'm going to ask you a question. I have a challenge for you. Have you looked at this the word scramble today?
Huh?
Have you looked at the word scramble?
No, I couldn't figure it out.
Did you try?
I don't.
Let me give you a hint. You're in
I
fourth.
don't want to try it.
You're in 4th grade, correct?
But I had an answer for 24.
Okay, Serafina. I'll let you do 20. But I'm gonna let you do it. Hold on. I'm gonna ask you this question.
Oh, okay.
You're in the 4th grade, correct?
Okay.
Yes.
Okay, we're gonna put it back on the screen. Look at this one. You have 2 S's, an X, and an E. There aren't that many words in math that has an E and an X inside. Can you think of a word that has an E and an X for math? What about, if I say, I'm going to give you a hint, okay? What is 4 plus 7?
4 plus 7 is 11.
No. What type of math sentence is this?
Addition.
Okay, it's an addition sentence. Okay. Another name for a math sentence for this problem is called my what? Look at my face.
Problem.
Look. What if I give you? Look. I'm giving you a whole bunch of what?
Emotions.
Oh my
he's
goodness.
So close. Okay. All right. Expression. Expression, Serafina, because I like you so much. My producer's in the back, Natasia, whatever her name is pronounced, is going crazy in the back. And look, it's expression, okay?
Okay.
So let's go to your question.
24.
All right, which one you want to do? A, B, C, or D?
D.
B as in boy?
D as in dog.
Oh, you going to do it again?
Yeah,
7.
I have another answer.
7, 3. Were you watching the show?
Huh?
Were you watching the show?
No.
Because somebody saw it another way, too, so hope it's differently. Go ahead.
Oh.
Go ahead. Tell me what to do.
I'm not sure if they have. But mine was 7 times 4 is 28.
Go ahead.
7 minus 3 is 4.
Yeah, we used this way already.
Oh.
I'm sorry. Somebody beat you to that way already. So we can't put your name I had extra time, okay?
Okay.
But continue to watch the show in the next 4 minutes. We're going to pick a winner, okay?
Okay.
I'm going to let you know it's been a joy talking to you today, okay?
Okay.
And remember to call back next Monday and Wednesday where you'll see me at 5 o'clock again.
Okay.
Bye-bye.
Bye.
I tell you, that Celestina, she knows her stuff.
Yes, she does.
Oh, wonderful. Just beautiful.
She's a wonderful representation.
She brightens up my eyes when I talk to her. I swear, I don't know what it is about her.
You need a close-up on your glasses.
Oh, well.
You need a close-up on his glasses. Spider glasses.
Let's go to Khadijah. Khadijah's calling back with a division-type fraction problem or something. Khadijah, what do you got?
Hi.
Hi, good to have you back. 5 minutes, let's go with our problem. Right now, Khadijah, we want to get you through.
2 9.
2 9. Yeah, do you mind writing? That'd be great. Thank you so much.
Divided by 3/7.
Divided by 3/7. Well, Khadijah, go ahead and lead us on. What do we do?
Find the reciprocal.
Yes. Do we change the 2/9 in any way or keep it the way it is?
Keep it.
All right. Always keep the first fraction just the way it is. And what do we do with the division symbol operation?
Make it multiplication.
Yes. And then what do you say about reciprocal? What would reciprocal of 3/7 be?
7/3.
Beautiful job. And like Mr. Pugh did before so beautifully, he did some cross cancellation. Do you see any cross cancellation you can do here?
Can you say that again?
Do you see any numbers that will cancel each other out in any way? Or do you want to just go ahead and multiply?
Go ahead and multiply.
So let's go do it there. Khadijah, what's 2 times 7?
14.
And how about the 9 times 3?
9 times 3 is 27.
And is that our final answer, or do you want to try to simplify that down?
Leave it.
Leave it. Excellent job. Because you didn't go too far. You went far enough, but you didn't go too far. And you stopped the problem right there because there is no GCF or common factor. Nothing goes into 14 and 27 at the same time, so therefore we are locked in. Can you say that whole fraction? How does it say the answer?
14 over 27.
Well, without saying over.
14 27.
I love it. I love it. So guess what? You are in our...
Can I do another challenge?
Another challenge? Can you do it real fast? You all ready to go?
Yeah. Can I do the word scramble?
Okay, the word scramble?
Yes.
Not the one we already just gave out in the air, is it? Well, maybe you're a good listener. What was the actual answer?
It took me a long time to figure it out because I couldn't find a word.
Okay.
So then I looked at my other homework.
Okay.
And I found it out. I found out the answer.
Okay, drum roll.
Anti-expression.
And what's your answer, Khadijah?
Expression.
Let's find out. Peel it off. It does say expression. You're going in twice into our treasure chest of fun. And guess what? I think it's about time to go ahead and pick our winners. Do you have anything else you want to add to the show, Mr. Pugh?
I want to say, Amaya, please go to our website and text in your question because we don't have time to take any more callers today. And I want to thank all the callers who calling in today. I really appreciate it because you made the time go by really fast, and it shows how many great students we have, out in our county today, and how wonderful the teachers are preparing you guys for everything, for life, not only for the test, but for life.
That's right. It's not just about testing. It's about learning and having life skills. So since you're so handsome and lovely and debonair, I'll let you pick our winner today, Mr. Pugh. It is a very exciting time in our lives to see, out of all those people,
the winner is Mr. Pugh. The winner is Amaya.
Amaya! Come back on next Monday when we'll be happy to have Count on Us on the air again. And just make sure you can always...
And remember, you can always count on us.
Count on us, man. This guy's my buddy, my bro.